Hey everyone, I just wanted to make a quick tutorial on some of the things that I wish I knew while I was writing a load of Python tools. I've written a load lately. We're going to go through how to make this. This is basically, I'm going to select a whole bunch of tools. I'm going to go create a node, and it's going to append a node underneath each one. They're going to be put in the right place. They're going to be renamed based on the naming of our incoming geometry, and we're going to turn on a parameter. So by default, this delete geometry but keep points isn't turned on with the add. It isn't even possible to turn it on unless something's connected. We are going to do a whole bunch of stuff. So let's get started. Okay, so first of all, I'm going to create a new tool on a shelf here. I have a shelf called tutorial, so I'm going to use that. Let's go ahead and call this thing create nodes. I'll name it as such, create nodes. Hit apply and accept. And okay, so if we edit this tool, we have some things we can write in here. We're going to start off by doing a quick check. So in order to get basically a tuple of all of the selected nodes that we have, we need to do a few things. We're going to say import who, and then we're going to say nodes equals who dot selected nodes, like so. And I'm going to tell it print nodes, so we can see what's happening here. Hit apply and accept. I'm just going to open up a Python panel here, Python shells, create a brand new one. There we go. So I'll select this, I hit create nodes, and you can see here we've got who.up node of type test geometry pighead at this location. Cool. If I select multiple nodes, it gives me all of them. So okay, who node of SOP, test geometry pighead, and then SOP type rubber toy, and then squab, blah blah blah. You get all of that. So what I want to do is check if I have something selected, because if I click this at the moment, this is actually doing something. And let's just tell the user, hey, you didn't select anything. So let's do that. Let's say if the length of nodes, which is what we call this thing here, is equal to 0, then we want to do something. We're going to say who.ui.displayMessage, and we're going to just say please select something. There you go. Hopefully nice and friendly message for our end user. And this is just a quick way of making sure nothing executes unless something is actually selected. So that's cool. And we can see that in action here. If I go apply and accept, I'm going to go create nodes, and it's going to be this warning, hey, please select something. You didn't. So that's all good. Let's drop down here, and we're going to say else. So if something was selected, if the length of this tuple of nodes is longer than 0, which means something is selected, then we do something. So let's start with a few things. I'm going to get just the first thing we select at all times for now. So I'm going to say nodes, I'm going to put these square brackets on the end and choose 0. So this is going to pull the 0th thing in that tuple. So if I say print nodes, or more accurately print nodes with the 0 in there, and let's just call this node. And now, in fact, let's do this properly. So node equals nodes and the 0th thing, and we're going to print node. So now if I grab all of these and I go create nodes, you can see it's only going to tell us, hey, you only pulled the test geometry pighead. If I select something else, the first thing I selected was the rubber toy, it should, yeah, so rubber toy. So now we've got that, we want to grab some basic things off of this. So that's our node. Let's grab the path to this node. So the path equals nodes, this 0 thing here, dot path. It's fairly simple. We'll say print print path. Apply and accept. So let's grab some stuff, create nodes. Okay, so our first thing selected was the pighead, and it's printed the path to it. So we've got the node and we've got the path, which is pretty good. What about the root? We might want to grab that, so let's do that as well. We're going to say root is equal to, now this one's a little bit more complicated. We're going to say path, and we're going to basically get rid of everything up to a certain point. So I want to say path.rfind, and I want to find the first / and we're going to just return that. So what this is essentially saying is, similarly to how we've picked out a particular item in this object, we're going to say from the path, find us everything up to this. So you've got find, you've got rfind. Rfind is reverse, essentially. So we're just going to find everything up to this. So what we should, in theory, do is, if this is our path, it's going to search. Oh, I found the / and that's where I stopped. And so we end up with this. So let's see if that actually did that. We'll just print root, line accept, select something. Okay, it did it. We still want to add that / back in. So what I'm going to do is I'm going to tell it, hey, this is technically a number that this is returning. So I'm going to say +1. So we just get one character extra the other way. And if I do this now, yeah, there we go. Object, GO1, / perfect. So we've now got some key information about where everything's taking place. What we've got selected, we know what the node was, what the path to that node is, and what its route is. So that's all good. Let's do a couple other things. Let's find out its position. So we're going to say pos equals, and we want to say node dot position. It's nice and easy. We'll go apply and accept. And we should probably get it to print it so we can see something happening. So we'll say print pos, hit apply and accept here. If I select this here, create nodes. Okay, so what this is the position of the node in the network view itself. So we can pick this up later. Let's say when we know we're going to want to place a node underneath this, we can have it look this position up and use that to drive where it goes in space in the network view. So we can lay networks out super conveniently. So we'll dive inside here again. Let's get some other bits. What might we want? I'm going to say we want the node name. So this is kind of funny. Technically what we're getting, remember these tuples we were getting here? This is technically all the information we're getting when we return this node thing. But it's being generous and it's presenting us with just the name of the node. But it's giving us more information than that. We just want a simple string that says, hey, this is the name of the node. So let's say name, and we'll say node dot name, and name equals node dot name. There we are. And we'll print name. So what this should do, we'll do it on the rubber toy this time. If I run this, okay, test geometry rubber toy. It's given us the name correctly. So this is some really easy and key stuff that we might want to work with. Let's put some comments in here real quick. So we're just going to say get node information. That'll do. So we've got 5 things here that are all sort of key bits of information to the node, where it is, what its position is, and a whole bunch of other stuff. So now, how do we create a node? Well, let's start by doing exactly that. We're going to say who.node, and we're going to pick the root this time because we know we want to create it in this object GO1. It's the same root location as the test geometries. So we say who.node root. I'm going to go create node and add. So we hit apply and accept, and with this selected, we're going to go create nodes, and you can see it created an add. Now, I didn't know where to place this. We didn't give it any information like that, so it's placed it at 0, 0. So this is the center of our network view. This isn't obviously what we want. We want it placed underneath whatever we had selected. So let's do that. Say edit tool, and we're going to come in here. We're going to say add.setPosition, if I can spell, and we're going to use a who.vector2, and we're going to basically tell it, hey, give me pos, but give me the 0 component of that, which would be x, and then give me pos, and give me the first input of that, or the first component of that, which would be y. And then we're going to close that off. That's our vector, that's our set position function, and we hit apply and accept. So now, if I select something, go create nodes. Oh, add is not defined. What's going on here? I've done something wrong. Oh, okay, so we didn't tell it that this was called add. So this add sop, we're just going to say add equals, now this could be called whatever we want. It's just important that this is consistent with this. This is an actual name of a node, a particular node type. So we can go in and find this. I can show you how to find different node types later on. But if we go add equals who.node.row, yep, cool, set position, apply and accept. Oh, hit cancel. I think it should be fine though. If I go create nodes, well done, Henry. Add equals that, apply and accept. So now if we run this, there you go. So you can see an ad's been created directly on top of our pig head. So we can obviously give it a bit of space. We're going to say edit tool, and rather than just use the Y component, let's say it's Y component minus, I tend to go 1.2 to space it out. So we're going to grab that, go create nodes, and now it's created the ad directly underneath our pig head, which is exactly what we wanted. But we can do better than this. So let's go into create nodes again, and we're going to set an input. So we'll say add.setInput, and so we can do a few things with this. We're going to say the 0th connection, and with an add sop there is only one. There it is, it's only this. There are nodes that have different inputs, so if we put down like an attribute wrangle, here we are, this has 4 inputs, and obviously there are nodes with multiple outputs. So if I put down a velum constraints, you can see here this has 3 outputs. So typically with the set input, we want to go, the input to actually input here is 0. In the case of an add, that's fine. If we want, using a wrangle or something like that, we might want to say 1, which would be this input, or 2, or 3. So that's all good. We're going to say we want it to connect to node, which is our node we have selected here. Now, if this was a node that had multiple outputs, we could put a third option in here, which would be our, say, velum constraints different distance here. We could say, okay, give me the second output of this, so I could say 1, and this would be this one. Or if I put 2, it would be this one. Because we're just using test geometries, we're not too worried about that. I'm just going to return 0 and node, so we don't have to worry about the outputs, but it's there if you need it. So let's go ahead and see if this worked. Select our pig head, create nodes, and voila. So I identified where this was, created a node at the same place, then it connected it and put it in the same position, but a little bit underneath. Great, this is doing some cool stuff. So what else can we do? Well, as I said earlier, we're going to change the palm. So this is a parameter over here that is called keep. You can see the parameter name. We're going to say add.palm, and then we're going to specify keep, and then we'll say dot set, and because this is a tick box, we can give it a number, so we can say set to 1. There are examples where you're going to want to put an expression in there, so you can use a set expression, and then you'd put in, you know, whatever you wanted to put in. But in this case, because it's just a tick box and a number, we can say 1, which means on. So let's see what that does. Select an object, create nodes, and it's done it. Delete geometry, but keep the points. So that's all really cool. And just to prove it works, we can run it on something else. It runs on that, or runs on that. Nice. So, okay, let's dive inside this again and make another change. Let's change the color of our node. We'll add dot set color, and we're going to say who.color, and we'll just go 1.0, 0.0, and 0.0. So this is going to make it red. Let's go apply and accept, select this, and we'll create nodes. That's quite garish, that node. I don't really like the color. Let's try and fade it a bit. Let's go by 0.3, something like that. Apply and accept. And again, there you go, that's a much better looking node. So now we've got that. What else can we do to it? Well, we can set its name. So let's do that. We'll go add.setName. And I think we're going to want to pick, as I said earlier with the version I've made previously, we wanted to grab the name of our node and use that as the input. So with the set name thing, we've got our node name, but obviously this returns this long thing, and I don't really want the test geometry bit, I just want like the pig head bit. So again, we could do the same rfind function. The problem with this is if it didn't find something, it would be a very short script, but I don't think it's necessarily the worst thing in the world. Let's go name equals, and we're going to say name, open square bracket. So we want to do it the other way. So we're going to say name.rfind. We're going to search for that underscore here, and we'll say +1. So we keep, we overlap that as we'd expect. We'll put a little colon there, apply and accept. And actually, let's make sure we finish that same name function. So we're going to want this to be called, let's just say str, so we can declare it as a string, and we'll put in brackets name. So apply and accept. We run this. Okay, so it did it correctly. It trimmed the name down right up to this underscore, and it pulled up the pighead1 thing. Great. I think I'd be curious to know, is that going to work if we had a box and nothing had an underscore in it? Yeah, so that's going to fail. We might want to change that up. We don't have to put something in like this. I just wanted to show an example of how we could use the name. So what we'll see, we'll leave it for now because we're only going to work on test geometries, but obviously you don't have to use this this name bit. So let's say str name, and then let's add something onto the end of it. So we'll say 2 underscore points. It's important to put those underscores in because Houdini names can't have spaces. So if we hit apply and accept, remove that, and okay, and let's click this. Okay, cool. So it goes pighead1 to points. That makes sense. But there's a problem with this. If I were to run this again, I get something that failed. And the problem with this is the name is not unique. What Houdini's trying to do in this instance is it's trying to set a name, but something's already called this. So we need to add another thing in here. We're going to add a unique underscore name, and we're going to set that to be true. So what this is going to do is it's going to basically look it up, and if something has the same name, it's just going to append a number to the end of it. We can set this to false, so we can force things to have completely independent name, and if something is already called that, it can't be called something else. You may want that in your script. Not all the time, but it is possible. So let's go ahead and try this. We're going to say create nodes, did it the first time, and then I'm going to go create nodes again, and you can see it did it again this time, but it appended a 1. So that's how I would do that with the name. So that's all good. What can we do now to make this run over everything? Because the problem right now is if I grab all of these, I go create nodes, it's only going to do it to the 0th in our selection. So we need to do something to update this a little bit so that it runs over everything. So let's put this in a for loop. I'm going to do a couple of things. We're going to first of all, I want to start a counter. So I'm going to say count equals 0. And then I'm going to say for n in nodes. So remember, nodes was our thing up here. So this is basically going to return each thing. We want to select all of this, tab it over. And okay, so what do we want? So rather than grabbing the 0th primitive, we want to grab our count. So what we need this count to do is each time it iterates through this, it looks at the first thing, it goes cool, then it adds another to count. So we can say count plus equals 1. So now it's going to go, let me just add a comment here so we know what we're doing. Create node. So what this is going to do is going to loop. Once it's done the first one, count will then equal 1. So we can use this here to pull a different node out of this selection. So if I say use count, we'll go in both here and here, then we should end up with something that works. Let me just double check we're not pulling, the pos is fine. Okay, this should all work. So now if I go apply and accept, and I'm just going to delete this, let's select all of these, create nodes, and there you go, it pulled the pighead1 to points, rubber toy 1 to points, squab 1 to points. We can do this in a way, so if we wanted to, we could comment this thing out. So if we had something without an underscore in the name, of course, we might want that to work. So I can show you an example with the box on the end here. The downside of this is obviously these will all be called test geometry, so we obviously might want to change the names. But let's go ahead and do that, and there you go. You can see these names are a bit long, so maybe the simplest solution is to do this. We can obviously set the names of these nodes themselves, but this is nice and simple. So I'll go create nodes, And there we go. So this is just a wildly simple sort of all the things I wish I'd known when I started out doing a bit of Houdini Python myself. I know this has probably been information overload for you, but this is definitely a thing to look at in terms of how to get started and just how to lay some nodes down and start coming up with your own templates and bits and pieces that you use all the time. For me, I find it so much quicker and easier to use than an HDA. HDAs are annoying to manage in my opinion, but that's for the community to debate. Hopefully this has been useful to you if you're starting out. This has been in Houdini 19 with Python 3. If you're still working in 18 and below, you may be working with Python 2, so this will be fairly similar, but certain things like print functions are going to be slightly different version to version. Worth double checking if you're using it. But anyway, hope this has been useful, and I'll see you in the next one. Thanks, guys.